Okay, let us start the lecture. Today our topic is green equivalences. Green's equivalences. ये विजिबल है सब?
जी सर।
Okay. So first we define the left principal ideal and right principal ideal. Okay. Left principal ideal and right principal ideal. Let S be a semigroup and A belongs to S. The smallest left ideal of S. The smallest left ideal of S containing A is S A union singleton A. And is denoted by S1A. We call it the principal left ideal generated by A. ये जो आइडियल है ना, इसको हम कहते हैं लेफ्ट प्रिंसिपल आइडियल. We call it the left principal ideal generated by A. Okay. Generated by this element A. Similarly, the smallest right ideal containing A is denoted by AS1, and we call it the smallest, and we call it the principal right ideal. Okay, we call it the principal right ideal. We call it the right principal ideal, not principal. It is right principal ideal. Okay. It is right principal. It's called right principal ideal. Or the right principal ideal. Right principal ideal generated by A. Generated by A. So left principal ideal and right principal ideal generated by A. Now we define two-sided principal ideals. Two-sided principal ideals. That's left as well as right, okay? The smallest two-sided principal ideal. The smallest ideal, you can also say two-sided ideal. The smallest two-sided ideal. Two-sided ideal generated by A is denoted by S1 A S1, okay, and we call it the smallest two-sided principal ideal generated by A. We call it the smallest two-sided principal ideal generated by A. Two-sided, left side, right side, and two-sided. We call it the smallest two-sided principal ideal generated by E. These are principal ideals, left, right, and two-sided. Now, based on these ideals, we define the following relations. So let S be a semigroup. Let S be a semigroup. And A comma B belongs to S. We say A is L related to B. It's cursive L. If the principal left ideal generated by A and the principal left ideal generated by B are same, if S1A is equal to S1B. Similarly, similar way, we say A is R related to B. R related to, this is our relation. We say R related to B if the right-sided ideal, principal right-sided ideal, that's this one, AS1 is same as BS1. And we say A is J related to B, J relation, okay? J related to B if the two-sided ideal generated by A and B, they are same. This is same as S1B S1. So these are the definitions. Now we show that these relations are equivalences. Show that the relations show that the relation is L, R and J are all equivalences on S, on a semigroup S. They are all equivalences, okay, these relations. मैं L वाला दिखा दूंगा, बाकी आप खुद कर लेना, ठीक है. They are similar actually. So, solution. Clearly this ideal, this thing is equal to same. They are both same sets actually. For all A belongs to S. So that is A is L related to A for all A in S. So therefore L is reflexive. Therefore L is reflexive. Now if AB belongs to S such that A is L related to B, okay, then S1A is same as S1B by definition of L, which implies S1B is same as S1A, and this gives B is L related to A. So therefore L is a symmetric relation, or I can say L is symmetric. L is symmetric. So finally we choose three elements, and we'll see that this relation is also equivalent, transitive. Now we have three elements B, A, B, C. They are in S such that A is L related to B and B is L related to C. So then by definition, then S1A is same as S1B and S1B is same as S1C. This implies S1C is equal to S1B, sorry, S1A, S1A. S1A, okay, S1A is equal to S1C. So thus this relation is also, therefore from this it's A is L related to C, A is L related to C. So thus L is an equivalence, L is equivalence. Thus thus L is equivalence. L is equivalence. तो ऐसे आप करोगे ये R and J, they are also equivalences. Okay, now we have a proposition. Proposition. Let's take let A and B belongs to, they are elements of semigroups. In this proposition we will discuss the characterization of L relation. Let A be elements of a semigroup S, B elements of a semigroup S, then A is L related to B if and only if there exists xy in S1, there exists xy in S1 such that xa is equal to B and yb is equal to A. Also this A is or related to B if and only if there is two elements, say U and V, there exist U, V in S1 such that AU is equal to B and BV is equal to A. Moreover, this A is J related to B if and only if A is J related to B if and only if there exist, say, elements, let's choose UV, you can choose any, in S1 such that it's U A V, there's a UV XY, 4 elements for this J relation. UAV is equal to B and XBY is equal to A. Okay, let's prove this theorem. अब इसमें भी मैं एक ही पार्ट करूँ. Okay, I will prove this last one है G. let's choose A. B belongs to S. Now if A is J related to B, then the two-sided principal ideals, they are same, generated by A and B. This is same as S1. So this is the smallest ideal containing A. This is also the smallest ideal, two-sided ideal containing B. So since this A, since or you can say B, since B belongs to S1, B S1, इसका element है S1, B S1, which is same as S1, A S1. तो B इसका element है, okay. So that means B is actually the product of three elements, element of S, then A, then again element of S. So there exist what U V in S1 such that this B, it's equal to UAV. तो ये आपके पास एक इक्वेशन आ गई जी रिलेशन के लिए, UAV is equal to B. Also now this A, अब हम A जो है it's always here S1A S1, but this thing it's equal to S1B S1. So there exists say X Y in S1 such that this A is equal to X B Y as required. This is the proposition. In the next proposition, we will see that this R relation, it's right congruence, and the R relation is left congruence. And these relations are called Green's equivalences. Okay, ये सारे relations जो आपने define किए हैं ना, they are all called Green's equivalences. Okay, next proposition. Next proposition is L is a right congruence, right congruence, and R is a left congruence on S. L is a right congruence and R is a left congruence. इसमें भी हम एक ही पार्ट करेंगे, वही प्रूव L is a right congruence. The other part follows on similar lines. The other part follows on similar lines. So this L is an equivalence relation. Right congruence क्या होती है? An equivalence which is also a right compatible. Since L is an equivalence relation, equivalence relation. So therefore we only need to show that we only need to show that this L is left compatible on a semigroup S. On a semigroup S, यहाँ पर एक proposition में L is right congruence and R is left congruence on S. Okay, on a semigroup S. On a semigroup S. So for this we choose a pair in L. Let's choose this pair AB in L and S in S. राइट compatibility के लिए हमें राइट कॉन्ग्रुएंस हमें चाहिए और लेफ्ट राइट एल इज राइट कॉन्ग्रुएंस. सो हमने क्या लिखा, वी प्रूव दैट एल इज राइट हमें प्रूव करना है ना. तो वी शो दैट एल इज राइट कंपैटिबल, नॉट लेफ्ट, इट्स राइट कंपैटिबल. ओके, राइट कंपैटिबल हमें प्रूव करना है, राइट कंपैटिबल. ओके, तो राइट कंपैटिबिलिटी के लिए अब ए एस और बी एस भी एल में होना चाहिए. नाउ दिस बाय प्रपोजिशन, बाय अबव प्रपोजिशन, by above proposition, it means that there exist x and y such that so by above proposition by above proposition there exist x comma y in S1 such that, so left means this x on left side, xa is equal to b and yb is equal to a. Okay, हमें ए एस और बी एस चाहिए. ठीक है, ए एस एंड बी एस. सो दिस गिव्स these two equations, they give this gives we have xa, we can write here xas equal to bs and ybs multiplying forward by s is equal to as. That is x as is equal to bs and y bs is equal to as. So for the elements as and bs, we have elements x and y in S1 such that x as is equal to bs and y bs is equal to as. So this by definition it follows that as bs belongs to L. So therefore L is a right, therefore L is a right congruence. L is a right congruence. Now let's define the join. Okay, join and meet. Definition. We know that join of equivalences is again an equivalence and meet of equivalences is again an equivalence. Okay, let's introduce two more letters. That's H, cursive H and cursive D. The meat, okay, the meat of L and R, that's actually the intersection, is again an equivalence, on S, and is denoted by H relation, and the join is again an equivalence, on S, denoted by the D relation, okay, D. So D is the join and H is the meet, and meet is intersection, okay. So join is it's L join R. That means it is the smallest equivalence containing L union R, which is actually equal to L union R E. So that is, this D is actually, अगर आप इस D को देखें जो आपने already किया है, this D is actually equal to L union R E, because this is the smallest equivalence containing L and R. And by join we mean the least upper bound of L and R. Okay, so these are the relations. Note, the relations L, R, H, D and J are called Green's equivalences. These are all called Green's equivalences. Okay, note, the relation is L, R, then we have the J, then H and D are called Green's equivalences. They are given by Green, okay, mathematician J.A. Green. So the meat is simple, it is interesting, but join is very difficult to describe it. I will show that actually these congruences, these equivalences, L and R, they commute. So when we know that if the relation is rho and sigma, if they commute, ये result हमने किया है, if they commute, then अगर ये equivalences हो गया और commute भी करेगी, और it's true for शायद, I think it's true for any relations, that if the relation is commute, then their join is actually the composition. ये रिजल्ट हमने किया है. हम प्रूव करेंगे L और R ये commute कर रहे हैं, so that means the joint relation will be their composition. That's our next proposition. The relation is L and R commute. The relation is L and R commute. Okay, proof. प्रूफ हम इसका एक ही पार्ट करेंगे, एक ही इंक्लूजन हम प्रूव करेंगे. ओके, एक ही इंक्लूजन प्रूफ. प्रूव करेंगे. We show that L composition R is subset of R composition L. The other inclusion follows on similar lines. The other inclusion follows on similar lines. So assume, let's take a pair in L composition R, and we show that it is in R composition L. ओके इसमें बस 1 मिनट है मीटिंग में, आप फिर से ज्वाइन करना, इस रिजल्ट को फिनिश करेगी, इसमें 5-10 मिनट लग जाएंगे. So this we show that this pair is also in R composition L. By the definition of composition,